Okay, my friends, today's notes are less about this crazy difference quotient and more about some of the algebra you're going to face when dealing with this difference quotient. I do want to take a quick 30 seconds to recap how this is a slope and how it gives us the instantaneous rate of change. We all know slope is change in y over change in x, so we need 2 points to get a slope. 1 point would be at x, and that would be the y value associated with that point. This would be another point that would be not quite on x. It's a little bit away from x. And the smaller h is, the closer this point is to this point. So that's a point that's maybe close to x, and that's the y value. We all know slope is change in y over change in x. So if you look at these points, this is quite obviously a change in y. It's y2 minus y1, and this is that first x value minus that second x value. I just think it's good to keep that in mind, that we're looking at a slope as one point gets closer and closer to another, and of course once h hits 0, it's right on top. But the examples you've done so far have all been polynomial functions, have been very friendly, but we're going to start looking at functions that look more like 1 over x cubed, or maybe like the 5th root of x. I don't make them quite this nasty, but your difference quotients will look something like, if I was going to try and find this guy's derivative, it would be the 5th root of x plus h minus the 5th root of x all over h. When you apply the difference quotient formula, that's how this looks. And it just, as you look at this expression, if I right now try to plug in 0 for h, what's going to happen? If I try and plug in 0 for h, let me get a different color. This becomes 0, and this becomes 0. So I end up with the 5th root of x minus the 5th root of x, which is, this is going to make 0. I get 0 over 0. And 0 over 0 is not good. It means there's more work to do. So because you guys haven't worked with these types of expressions, probably since you were freshmen, the notes today cover how to deal with these complex fractions, how to deal with these crazy radicals, but we're still using this definition to make things work. It's going to be good for your brains. It's going to make you think. It's going to maybe be a little frustrating, but I know you guys can do it. And of course, I'm here to help. Just let me know how and when. All right, good luck, you guys.